Couple of things. So Logic Lab will be this Friday, 11 to 1. I believe it'll be room 519 in the Jackman Humanities building. We haven't got the confirmation yet, but check on Quarkus for the exact location. Yeah? Okay. A couple of other things. So there are recordings of all of these lectures on links to the recordings on Quarkus, and there's slides. This morning, I just remembered to post the slides literally 2 minutes ago, but they are nonetheless up now. So if you're frantically writing things down that are on the slides, don't worry about it. They will all be available to you online. Yeah? Good. Any questions? Any questions about the structure of the course? Administrative questions. Your first exercises are due this Friday at 4 p.m. Yeah? So if you have not yet signed up for Logic 2010, time is running short. And because I've been saying this over and over again, my sympathy will likewise be fairly short. If you get in touch at 6 p.m. on Friday and say, oh, I don't know how to install Logic 2010, please help. Now is the time to get it sorted out, yeah? Yeah.
Is there a way to check if they're being uploaded to the website?
Yes, so you go on the website. So there's a link on Quarkus, there's a link to download Logic 2010, the program that lives on your desktop that you complete the exercises on. And then there's another link to the Logic 2010 website where you can see whether you've successfully uploaded. So check there, it should show whether you successfully completed the exercise or not. Yeah?
Is there a way to submit multiple at one time? Because that was just one.
Absolutely you can. Absolutely you can. You just save. So after you complete a question, save and just go on to the next one. Right. And then whenever you next click submit, it will upload everything.
It only uploaded one.
It only uploaded one?
Yeah.
Oh, okay. So there was a clarification. Thank you. Thank you. You select the ones, you shift select the ones that you want to submit, and it'll select a bunch of them. Is this correct? And then you click submit. Okay. Thank you. Thank you. Logic 2010 is mildly mysterious to me as well, so. Further questions? Concerns? Okay. So quickly, I want to do a little bit of review, and then we'll get into derivations. So last time we were doing this stuff about, I won't go over negation. I think negation's straightforward enough. I very rarely have people have trouble with the very idea of negation. Conditionals, maybe we could go over a little bit more. So recall, conditionals have an antecedent and a consequent. And we always symbolize it as the antecedent comes first and the consequent comes next. That's how we symbolize it, but that's not always how the sentence is written. Very often, the sentence is not written in that order. Yeah? So we saw a few examples of that. So if X is the sentence, I am happy, and Y is I am raining, I am happy if it is raining, and if it is raining, then I am happy. You see those are the same, those sentences say the same thing, right? They have all the same implications, right? You're not saying totally opposite things with those two sentences, although you flip the order of the parts of the sentence around. Both of those sentences get symbolized as if Y, if it is raining, then I am happy, right? That's okay? So, and we talked about the rule for how you figure out which order they go in. Whatever's right after the if is the antecedent. So forget about what order they are in the sentence, in the written English sentence. Whatever comes right after the if is the antecedent. Except only if. There's one case, it's an annoying case. It was a nice, clean rule that you could easily remember and apply. If it wasn't for the complexities of natural language, only if flips it around. So only if says, wherever only if appears, whatever comes right after that is the consequent, not the antecedent. Yeah? So whatever comes right after only if is the consequent of the conditional, not the antecedent. Yeah? Why? Because saying if and saying only if are logically different things. So if I say I am happy if it rains, it's logically different than saying I am only happy if it rains.
So they're much the opposite
In a sense. So if you look at the truth table of the conditional, so we did this last time, so go back to that and look at the truth table of the conditional, and you'll try to convince yourself that, so you get intuitively that those are different claims, right? If and saying only if, those are quite different claims. And the truth table for if works out to, antecedent, then the antecedent comes after the if, and the truth table for only if works out if you have it after the only if. And so, yeah, is that, I think I explained it. There's a kind of ground level explanation that I can't explain more, unfortunately, in this class. There's a limit case of I don't know how to get deeper than that in terms of why this is the case. So, if I say if I'm happy if it rains, that's true in any case when if it's raining, then I'm happy. Yeah? If I say I'm happy only if it rains, then that can be false if I'm happy when it's not raining. Right? That's what makes that false. Yeah. There's a really good explanation of this on the discussion board on Quarkus, actually. So I'm very happy to see that you're using that discussion board. You're helping each other out. A student posted a really nice set of examples. So check that out. And it's a really nice sort of explanation of what's going on here. Do you have another?
Yeah, I was just going to say an easier way to understand this to kind of convert it to an if-then statement. So if I'm only happy if it rains, well then it's required for it to rain for me to be happy. So
right.
If it's raining, then therefore I must be happy. So
yeah.
That's an if-then, and then you just visualize it as well. So
good.
If it's raining, then I'm happy.
Good. So that is essentially what was on the Quarkus. So okay. Yeah. There's a fine balance with understanding in this class where it really helps to try to deeply understand it at the beginning, and then as we get more and more complex, there comes this tipping point where you're just better off not even trying to understand. It's just learning it as a skill. So we haven't hit that tipping point yet. You should still be trying to understand what's going on, but somewhere halfway through, deep into sentential logic, maybe when we get to predicate logic, there'll be a moment where you should start thinking of this as just a formal game that you're playing rather than something that you're trying to understand. Yeah. So that moment might happen at different points for different students, but at some point you're just going to be manipulating symbols rather than deeply understanding how this connects to your human concerns, just by way of warning. Yeah, so just as examples, I am happy. Sorry. Again, X is I am happy, Y is it is raining. I'm happy only if it is raining. I'm happy only in the case that it is raining, or I am only happy if it is raining. Was anybody alive in the 90s when this was anyway? Okay, so those are all symbolized the same way, right? So the only if also receives, remember we saw a bunch of stylistic variants for if, such as in the case that. So there's stylistic variants on only if as well. So be sensitive to those. Yeah? Okay. And this is something I'd really like to emphasize, the crucial nature of the comma. So the comma is when you're looking at an English language sentence and trying to symbolize it, the comma is an incredibly important part of that sentence. It tells you how to chunk it. Basically, it tells you, remember we were talking about the main connective? It gives you a hint about where the main connective is in that sentence. So let's look really quickly at an example. Okay. Please forgive the clumsiness of this. I'm going to try some mildly unfamiliar technology. So, right. Okay, so here's a sentence. We're going to try to symbolize it. And the symbolization scheme is V is Veronica leaves, W is William leaves, and Y is Yolanda leaves. Yeah? Is that fairly just the names give us the symbolization scheme? Okay, so so we're going to chunk this. This sentence has 3 conditionals in it. Remember we saw last time that if you have 3 conditionals in a row, that's ambiguous, right? You need to be able to say which is the main conditional, and then there's a subconditional somewhere. So this is the structure of the sentence is that there's 3 conditionals, but one of them is the main connective, and one of them is a subconnective. And the comma is your hint. The comma tells you where to break it up. What are the major chunks of this sentence? So when you're doing this, it's helpful to like draw on the sentence. So you might say something like, so here's the comma, and that tells us where the break in the sentence is. So then this is a chunk, and then this is a chunk. Yeah? So now we've got if Veronica doesn't leave, if William doesn't, comma, then Yolanda won't. Okay, and there's 3 conditionals in there, right? And you know that the comma tells you where the major connective is. So what we can do is just kind of rough out what we have. You know there's something like that, yeah? Does that make sense so far? We got 2 chunks of the sentence, right? Inside this bit is another conditional that we haven't figured out yet, but we've got this thing conditional, then Yolanda, won't, negation y. Yeah? Okay, and then you just look at the other piece and try to figure out how this conditional works. So if, and then just kind of ignore the if for a second, Veronica doesn't leave if William doesn't. So where's the if? And then the antecedent is right after that. So what's the antecedent of this part of the conditional? W, and it's not W because William doesn't. So not W, then Veronica doesn't, not V. That's how you symbolize that sentence. Yeah? With multiple commas? I don't think I have an example with multiple commas. I believe there's some in the textbook, though, so you could check that out. Or do I? No, here's an even more fun one with no commas. Okay, so this is looking ambiguous. Yeah, so we will, as we go along, do multiple commas, but hopefully it'll be relatively clear. Like once you get the feel for this, it'll be relatively clear what the major parts of the sentence are. Okay, so same symbolization scheme, right? Still W is William will leave, V is Veronica will leave, Y is Yolanda will leave. Okay, now what do we do with this? Okay, so William will leave only if Veronica leaves, then so will Yolanda. Okay, so where's the if you were going to chunk that sentence into 2 big pieces, how would you chunk it? How would you break it up? Sorry, yeah.
To the left of the only if and the right of the only if?
Yeah, so William will leave only if Veronica leaves, then so will Yolanda. Okay, so whatever comes right after, so think about our rules. Whatever comes after the only if is the what? Consequence. So that means this part is the antecedent. So William will leave, W, then whatever the heck this thing is. Yeah? And then we say, and then just look at, so now we can just ignore the William will leave only if and just pay attention to if Veronica leaves, then so will Yolanda. That's just, so where's the if? Right at the beginning. So this is the what? The antecedent. So Veronica leaves, then so will Yolanda. That's just equivalent to if Veronica leaves, then Yolanda leaves. So V, Y. Yeah? Yeah?
If we go back to the previous slide, why is it not W goes to not V and not V goes to not W?
Right. So so on this one, so the question is, why is it not W leads to not V rather than not V leads to not W? Because not W comes right after the if. Right, so this if applies to that then. So this if then statement is the main connective. And then Veronica doesn't leave if William doesn't. This if attaches to William doesn't, and therefore it's the antecedent. Yeah? Yeah.
For the second example, aren't you supposed to flip because there's an only if?
Well, okay, so flip it how? So there's a kind of double flip.
Like make it V, if V, then W, then.
You got it?
Yeah.
Yeah, so this says William will leave only if. Now, only if flips it in the sense that you're used to, the simplest case is if then, where the antecedent is the first part of the sentence and the consequent is the second. But in this case, William will leave only if. This means this part is the consequent, this part is the second part, even though the only if appears in the middle of the sentence, it doesn't like make this the antecedent and this the consequent. It's just whatever comes after only if is the consequent, therefore that's this thing. And then whatever the other part is, if it's not the consequent, it's the antecedent. There's only two options, so W is the antecedent. Yeah? Okay. There's a bunch of examples in the textbook. There's a bunch of examples on Logic 2010 if you want more practice with this stuff. And we will do much more of this stuff. We'll do much, much more of this stuff. Okay? That should be enough to get you through this week's exercises. And then we will ramp up complexity from there. Any more questions about this stuff before we move on to derivations? Okay, let's do derivations. So, whoop. Okay. So, I said at the beginning, this course, so this is, we're doing the third basic skill that you're going to need for this class, derivations. I said this course is mainly about arguments, and so far we haven't done any arguments. Derivations is where the arguments part comes in. Right? So derivations are pretty much the best arguments that you can have in the sense that if you derived something from something else, then you can tell that you've got a truth-preserving argument. That is, we want to argue in such a way in a deduction, in a deductive proof, and that's what a derivation is, a deductive proof. If the premises are true, then the conclusion must be true as well. Must be true. And that was, again, our definition of deductive validity, right? How do I know the premises are true? You don't know the premises are true, right? So nothing that we're doing in this class, if you wanted to find out which premises are true, that would be science or something like that. So we're not doing science. We're not doing the truth of the premises. We are given premises and asked, given these premises, can you get to the conclusion deductively? Yeah? Okay. It will be clear what the activity is when we get into it. So we've got some rules, all right? And these rules are kind of guaranteed, certified, truth-preserving rules. If you apply these rules and you apply them in a very strict way, strict and careful way, you're guaranteed to move from one thing and preserve the truth value of it. So if the first thing was true, then you apply the rule, the second thing will be true as well. So he gets us from premises to a conclusion without introducing any doubt whatsoever. That's the deal. And we got four. We're going to start out with 4 rules. There's a bunch of rules that you'll learn. We're going to start out with 4 to keep it super simple, to kind of get the mechanics of derivations under our belts. And hopefully these will be obvious why they're truth preserving. So here's a real tricky one, repetition. So if I give you P as a premise, you can, in a truth-preserving, deductively valid way, infer P. Okay. Would anybody like me to go over that again? I know this is very abstract. Okay. We've also got double negation. So double negation is when you have, if you have P, you can infer not P. This applies to all of the letters, but P is the example. So, and similarly, if you've got not P, then you can infer P. So far, so good. This should all be super obvious. Okay. Here's a couple more. So we've got 4 rules to start with. 4 rules. Those are the first 2. Here's another 2, and they've got traditional Latin names. Latin being the philosopher's standard tool for making people feel small and dumb. Modus ponens and modus tollens. So modus ponens says if I have this conditional if P then Q, and I have P, well, I get Q. Yeah? That should be fairly obvious, right? So if it's true, if this conditional is true, if P then Q, and P is true, then Q's got to be true as well. So far, so good. And modus tollens, slightly less intuitive, but nonetheless still truth-preserving. If you've got this conditional, if P then Q, and you've got not Q, then you get not P. So if it's the case that if it's raining, then I'm happy, and I'm not happy, it's got to be the case that it's not raining, right? First two things are true. The third thing has to be true as well. Okay. Good. Okay, do we all accept? So if these don't strike you as clearly truth-preserving, I guess you should look carefully at the truth table for the conditional. There's a bunch of stuff, I won't belabor this too much. There's a bunch of stuff in the textbook where you can kind of convince yourself that these are good rules of inference. For now, I propose to just roll on and sort of say, yeah, those sound like good rules. I promise you these are good rules. We've tested them very carefully for several thousand years. They're good rules, okay? Okay, all right, let's keep going. And the rules also apply to complex sentences. Okay, so if I have the top conditional, it's not the case that if not P then Q, then if R then not S, and I have the first half of that thing, or sorry, the second half of that thing is negated, right? So you can see that the second line is the same as the consequent, but it's got a negation sign in front of it. Right, so you've negated the consequent of a conditional. Then you get the first thing negated. No, I screwed that up. Definitely screwed that up. There we go. See, I can tell that you're getting it by the way that you can error check my slides. Okay. Okay. Yeah. So, if you have the negation of the consequent, then you get the negation of the antecedent. That was which one? That was modus tollens, right? Okay. And notice that I didn't go straight to just if not P then Q. I did the double negation. So you got to be, this is one of the ways in which Logic 2010 will force you to do this. I will also be forcing you to do this on tests. You don't get to just ignore the part where you do the double negation. That's an extra step. So this derivation stuff is all about being super explicit about every single step in your argument. And that's how we make it an airtight argument. Because that's how people slip things into arguments by being unclear about some of the steps in their argument, right? So what we're doing here is just getting every single minute, silly little step very, very explicit so that we can guarantee that it's truth preserving. Yeah?
We can combine steps in the lines though, right?
That's right. So you can do several steps on one line, but you do have to do the step. So you'll see what that means. You'll see what she means by lines in just one sec. Okay so far? Okay. So a derivation does the following. It starts from some set of premises which are given to you. And students do weird stuff on derivation sometimes. They try to prove that the premises are true. You're not proving these premises. These premises are sort of like the gift given to you are these premises. You've got these. And now your job is to, by a series of applications of these rules, get to the conclusion. Right? So that's the task of a derivation. Given these premises, get to the conclusion doing nothing but these simple, tiny manipulations according to the rules. Okay, so this is straight from the textbook. Here's an argument. Here's an argument that we're going to try to do a derivation for. If Polk was president, then if Whitney was a president, then so was Trump. Polk was a president only if Trump was a president. Trump wasn't a president, therefore Whitney wasn't a president. So these premises, this was written in 2013. These premises were chosen because it's so obvious who was or wasn't a president, right? It's just completely obvious to everybody that Trump would never be a president. I had to take a moment when I came to this argument. I had a little break after I saw this. Okay. So, yeah, that sounds all right. No, that sounds good, right? No, that sounds like an argument. But can we prove that it's an argument? Can we prove that this is a deductively valid argument, such that if the first three things are true, then the last thing has to be true as well. So the first three things are our premises, and the last thing is our conclusion. And what we want is to get to that conclusion by doing these tiny manipulations one by one in order to get to the conclusion. So here's a symbolization for this, where if P is Polk is president, W is Whitney is president, and T is Trump is president. Do you want me to, is this fairly clear how we get there? So if Polk is president, then if Whitney was a president, then so is Trump. If P, 1 to 2? Okay, so 1 to 2, so we haven't done any of the inferences yet. These are all just given as premises. These are all just given as premises. We have not yet constructed the derivation that shows that these premises yield the conclusion. So we'll do that in just 1 sec, yeah? So this is not a derivation. These are three premises given in order for us to be able to derive the conclusion. And now we'll do that right now. So we do that? Yeah. Okay, so you're going to do several derivations in Logic 2010. I want to show you how to do them by hand because you'll be doing these mostly by hand, well, no, entirely by hand on the test and exam. So let's do that. Okay. Oh, no, not that one. That's the one. There we go. Okay. So we're going to do this derivation. We've got the first three things as premises. So, and this will be the sort of standard way in which they're written down. So if P, then if W, then T, premise 1. If not P, then T, premise 2. Not T, premise 3. Therefore, not W. That's the conclusion. Clear so far? Okay. Now we're going to write it out. Every single line gets a number, and every single line needs to be justified except the first line, or sorry, except the following type of line, where we just say the following. We say, line 1, we want to show not W. Okay. Oh my God. Please excuse my hilarious handwriting. I hopefully will get better at this as the semester goes on. So we want to show not W. Okay, and that's just us setting the task for the derivation for ourselves, right? We don't have to justify that line. That line just says, here's the job that we're about to undertake. Show not W. Okay. Now everything else, everything other than a show line, you need some reason to believe it. Okay, so now line 2, whoop, pardon me. So now on line 2, we're going to start using our premises to try to get to the conclusion. So we look at our premises, and we've only got 4 rules right now, right? We've got 4 rules to choose from. We've got repetition, which is just sort of like get the premise again. We've got double negation, which is just double negates. And we've got modus ponens and modus tollens. So you can use modus ponens if you've got the antecedent of a conditional, then you can get the consequent. And you can use modus tollens if you've got the negation of the consequent, you can get the negation of the antecedent. So step 1, there's really only one thing that we can do here so far. So we haven't got P, and we haven't got not P. We've got not T, however, right? So we can use not T somewhere. What we can do is use not T to do a modus tollens on here. So you can be really sort of like meticulous about this. We can say, you can just write it into the proof. Your premises, not T, premise 1. You kind of don't need to do that, but let's do it slowly and carefully. And then we've got not P, then T is premise 2. And so these are the justifications given for where did you get this part of the argument? Where does this come from? Well, it came from premise 1. And this part, it came from premise 2. Okay. Now, line 4, we are going to use line 2 and line 3. So we say line 2, line 3, and MT. So MT is the short form for modus tollens. And what does that get us? Not P. Not P. Don't go to just P because you're treating this is the sentence, not P is the sentence that you're getting is the antecedent of this. So you get the negation of that. And then you can do the following. You get P by doing line 4, dn double negation. Okay? Yeah?
Does the order of the arguments matter when you're using modus tollens, or?
No, not really. Not really. Like no, I don't think so. I don't think so. Because you've only got two things. One of them is a conditional and one of them is the consequent negated. So there's not really much room for confusion there. Yeah?
So are we expected to number our parentheses?
Well, oh, yeah, so yeah, are you expected to number them?
Yeah, like, for example, like line 2 and line 3, refer to not T as premise 1, and then,
Oh, that is wrong. Wow, that is wrong. That should be premise 3. Yes. Sorry, that was, all right. I was wondering, like, once again, how long it'll take me to make a mistake here. First line. Okay. So yes, you're expected to say premise 1, premise 2, premise 3. And a more meticulous human would have gotten that it was the third of those premises, not the first of them. So it's not arbitrary. You don't arbitrarily assign numbers to them. That was incorrect, and if I'd written down a test, it would have been incorrect. Yeah. Yeah.
And so then you can approach the set of premises in any order you like them.
So yeah, you don't have to use the first one first and the second one and then the third one. And in fact, I kind of could have skipped these two lines and just sort of like said premise on line 4. I could have said premise 3, premise 2, modus tollens. So I could have started with line 4 if I was being less picky about it. But I think we should start kind of slow. Okay. Okay. So now we've derived the line 5, which says P. We've done this in a truth-preserving fashion using nothing but the poorly labeled premises. Nonetheless, we've gotten there. So now what can we do with P? Yeah? Exactly. So we say line 5, premise 1. It's actually premise 1 this time, which is nice. And then that gets us if W, then T. Yeah? Okay. Yeah.
This is a clarification question. You're sort of switching between using brackets and not brackets.
Yeah. Either is fine. So if I just done if W, then T, that's probably a cleaner way of writing it. Yeah. Yeah. Informal notation is fine for the derivations. Yeah. Okay. Okay. So now what do we do? Yeah.
based on the third premise, you know that T is false, so modus tollens tells you that W is false.
Very good. Very good. So we've got premise 3. And hey, we used premise 3 already. Is it okay to use it again? Yes, it is totally okay to use premises as many times as you like. Yeah.
On line 6, do you need to say modus tollens after the two premises?
Yes, I do. Yes, I do. Thank you. Okay. Okay, so, yeah.
Also, do you need to put the premise into the derivation itself?
So, no. I did it up here just to kind of take it slow, but you can just say premise 1 and you don't have to do it. You don't have to do these two lines. You can if you want. You don't have to. Yeah? Okay. Okay. So, but now we did it. Look, we did it. So we've got not T, and we've got if W, then T, and from that we can get not W, which is from premise 3, line 6, modus tollens. And then on line 8, we say, on line 7, we did a direct derivation. And that's it. We got our conclusion. What we do is cancel the show line and draw a box around it. That's a kind of arbitrary action at this point. You'll see why we do that later, because in a more complex proof, there's a bunch of show lines. Yeah? Okay. Okay, let's do one more quickly, and then I'll show you how to do this on Logic 2010. Oh, boy. Okay, I'm definitely going to screw some of this up. Okay. So once again, always, always, always start with your show line. You're going to show that not W is not the case that if W, then Z. Okay. This is our premise 1. This is our premise 2, premise 3, and premise 4. Okay. So, well, you just kind of look around and see what you can do. At this point, we don't need a whole lot of strategy. We'll kind of develop strategies for handling these things. At this point, it's probably easiest to just start from like, hey, what have I got and what can I do with it? And what jumps out at me immediately is we've got the following. We've got not P, and if P, then X. Oh, hey, that's nice. So what I can do is get P from premise 1, 2, 3, 4, double negation. Yeah? And now I've got P. I can do something with P because I've got if P then Q on premise 3. Or sorry, P then X. So I get X from line 2, premise 3, modus ponens. Hey, that's good. I'm doing stuff. Look, I'm doing stuff. Okay. Now, so what have I got? So far I've got P. You can use P, again, you can use P as many times as you want. Once you've derived something, it's available as a kind of tool that you can apply wherever you want. So now I've got P and I've got X. Can I do anything with P? Well, I've already used this one and I've already used this one. So I can't really do much with P, but I just freshly got X. So let's see if I can do anything with X. Yeah?
Modus tollens with the second premise?
Good, good. So you can do modus tollens here because X is the negation of this. However, you got to be real picky about this and make sure that it's, so this is not the negation of this. What it is, what we want is not X. Which is, it is not X. It is logically equivalent to X. What's that?
You have to prove double negation again?
Yeah, so what we do not X from line 3, double negation.
Why do you do that?
Why? Just to be super picky. I think there are logical systems in which you allow people to do modus tollens with the like X as the negation of not X. In this system, and particularly in Logic 2010, Logic 2010 will not accept, if I just said line 3 modus tollens premise 2, Logic 2010 would tell you that's wrong. So kind of the reason I'm imposing it on you is because Logic 2010 will impose it on you. The real reason is like we want to be as picky as possible, right? This is where we're doing every single step. We do not allow ourselves any intuitive jumps. Yeah? Yeah.
Isn't it just one step though? Because we have X and then premise 2 is just negative X. So where's the second negative coming from?
Okay, so it's not the case. So the consequent of this is not X. Right? The consequent of this is not X. What we want, so modus tollens applies to, so if you've got sort of like circle, square, let's do circle, square, and you've got not square, right? Then you get not circle. But this is the sentence that equals the square in this case, right? This whole sentence. So you need the negation of the whole sentence. What's baffling is that they're logically equivalent. Okay, so whatever this sentence is, and it can, this whatever's in the square can be as complex as you want, remember? And this is a complex sentence. So you need the negation of that complex sentence. Okay, that's as much justification as I can give you. After that, it's because I told you so. And there's going to be some of that in this class. This is the way that our specific logical system works, and this is what Logic 2010 will accept. Okay, so let's blast through this. Let's get through this. So now we've got the negation of this consequent. So what we say is line 4, premise 2 modus tollens, and that gives us the negation of the antecedent. So if it's not the case that if Z then W. And hey, that looks familiar. If it's not the case that if Z then W, or sorry, this is the if Z then W is the consequent of this conditional. So we can do modus tollens again. We use line 5 and premise 1. Sorry, premise 1, modus tollens, and get it's not the case that if W, then Z. Oh, hey, look. That's the thing we were trying to prove. Check it out. We did it. Yeah.
Is there any like standard way for putting the line versus the premise? Because like in the other one you put 6 after the premise.
I think the order when you're showing which lines you're using, the order doesn't matter because again, there's so little room for ambiguity that it's like. Try it on. I might be wrong about that. Try it on Logic 2010 both ways. If it works both ways, then it's fine. I'm sorry to defer to the bizarre programming of Logic 2010 like this. It's not a very good reason. Okay, so we got the thing. Hooray! We got 2 more steps here. Line 7, line 6, direct derivation. Why do we do this? It'll be clear because there's actually, so on Tuesday next time we'll look at 2 other types of derivations, conditional derivations and indirect derivations. So you need something to say what kind of derivation it was. So look, on line 6 we got the conclusion, and now we can cancel the show line and box it off. Yeah? Okay. And again, why did I cross that out and draw this thing? You'll see. As we get deeper into this, why you would do that becomes clearer. Basically, because if you've got a derivation with multiple show lines, this stuff is no longer available to use. Right? You can't use this in other. So if you've got like 3 different show lines in the derivation, you can't like go into a closed off, boxed off stuff to use these premises. So once it's boxed off, you're saying that part of the proof is done with. We're putting it aside, and only stuff that's not been boxed off is available. If that sounded weird and you didn't understand it, hang on. When we get to more complex derivations, that will make more sense. Yeah?
Do you not include the line numbers in the box?
I don't know.
Okay, but you can. It's not like.
I wouldn't. So you mean like why don't I just go like this?
Yeah.
Nah, I wouldn't do that. Yeah. Yeah.
Don't you have to?
Do you have to?
Yeah, because you're referring to the lines within the proof, and so you have to have the identical, like otherwise 2, 3, 4, 5, 6 doesn't make any sense.
Sorry, what? Shush.
First, you know what you're talking about at each line.
Oh, you have to have the line numbers in there.
You have to include the 2, 3, 4, 5, 6 in your box, or else your justifications are arbitrary. Right?
You put line numbers to specify what you're referring to, and if you don't put
So you have to have these line numbers. Do you have to draw the box inside or outside?
Outside of the numbers.
Why does that make it an unjustified? Why does drawing it outside make it an
Because if you're saying line 2, premise 3, modus ponens, but you don't know what line 2 is, then
Well, if you didn't draw this number, then you wouldn't know what line is.
why are you putting it outside of the box if we're going to the effort of putting a box on it?
I think it's because I told you so. I think that's one of these ways. This is the convention. Basically, this is the convention. I don't understand why it would make it a less rigorous proof if literally we're talking about whether the line goes here or here. Is that what we're talking about?
Yeah.
If you excise the box information and like take it off of the actual line too, then that.
Sorry, what?
I think what you mean is if you take the box information out of that context
Yeah.
and just look at it, it's then unjustified because you don't have the numbers. But the fact is, it's still on the line.
Yeah. Yeah.
So that's fine.
Okay. I think I'm going to go with because I told you so in this case. I'll get back to you on whether there's some principled answer. I don't know if there's a principled answer why you do it on the inside or the outside, but I'll have to get. So far, because I told you so. Is that all right? Yeah.
The next thing that you're showing, would you like start back at line 1?
No, you absolutely would not. You absolutely would not. So if this is a show line and there's other stuff you need to show, you start at 8. So kind of I don't want you like crossing this line. I want to have a nice clean ability to read these lines. So if you've got multiple show lines and you're like crossing through it, I want to be able to read those numbers. Because at the end of this, what I'll see is a whole bunch of like lines. So sometimes there's like 3 or 4 lines. And if you're like writing over your numbers, then the person who's reading these can't easily read those numbers. So it's a legibility issue. Okay, really quickly, I have to show you this on Logic 2010 so that you can like do this stuff. We'll come back to this. I swear we will come back to this ad nauseum. All right, settle down. Okay, so we'll do one really quick derivation so that you can see just basically how this works. Okay, once again, you're going to do a derivation. You say select, and you select a derivation. And say OK. If you haven't done it yet, there will be nothing here. OK, you press Enter to give yourself a fresh line. And you always say show conclusion, and that'll give you the show line that you're looking for. And then in here, you type in the rules. Basically, it'll generate what happens when you type in the rules. So in this case, we're trying to show Q. We've got P. What do we do? Premise 1, double negation. And it'll give you the option of how you want to double negate it. I'll go if P, then Q. Right? We've got P as a premise, so premise 2, line 2, modus ponens. And then 3, we got what we're looking for. Yeah? Okay, you can draw up by right-clicking. You can get a list of things that you want. You can just type it in like that, or you can just type in on this column. Yeah? And we say save and submit. Are the mechanics fairly clear there? Okay. No. Okay, well, regardless, we're out of time. So, okay. Okay, thanks everyone.